In this video, let's talk about geometrical isomerism. And geometrical isomerism is under stereo isomerism. Stereo isomerism. Do that. So stereo isomerism is divided into two. Here we have what? Geometrical isomerism. Geometrical isomerism. And which I'm going to look at in this video. And here we have optical isomerism, which we are going to look at in my future video. Let's move to what? Geometrical isomerism. Now, geometrical isomerism occur in alkene and cycloalkene, where there's what? Where there's this restricted rotation along the what carbon-carbon double bond and carbon-carbon single bond in what cycloalkene. So geometrical isomerism occur in what? In alkene, where there's what there's what double bond. And cycloalkenes, cycloalkenes, where there's what where there's what in a cycle in a ring. Do you get? So there's always what a restricted rotation along the what carbon-carbon double bond. There's what restricted what rotation. That is, they are not what free to move. Do you get? Now in the what alkane like this, there is a what free movement of what rotation here. There's a what? There's a free movement of rotation here. Do you get? There's a free movement of rotation here. So the free movement of rotation will now result to what called conformation analysis, which I'm going to talk about in my future video, conformation analysis. But I'm not going to talk about that one now. But here we are focusing on what geometrical isomerism. In geometrical isomerism, there's always what a restricted rotation, and that restricted rotation occur in carbon-carbon what double bond and carbon-carbon single bond. It was cyclo. Do you get that? We are not going to talk about cyclo here, cycloalkenes. Our main focus is going to be what alkenes. So in the sense that there are conditions for a molecule to what exhibit what geometrical what isomerism. First, they must have a double bond. That is one of the condition for geometrical isomerism. One of the conditions is that there must be what a carbon-carbon double bond in the what alkene number one, and there must be what a carbon-carbon single bond in what cycloalkene. Do that. So first of all, the condition there must be a what double bond. Do that. Then you what we are talking about the alkene. There must be what a double bond. You really want to what take into this one here. Now, when there's a double bond here we have this stuff here. Here, and what here and here. Do that. So the atoms that directly attached to this carbon to two carbon to carry the double bond matters a lot. Do that. So all alkenes exhibit restricted rotation. That is, all alkenes have or exhibit restricted rotation. That is, they are not free to move. But not all alkenes exhibit geometrical isomerism. So for an alkene to exhibit geometrical isomerism, there are some conditions it must what satisfy. For example, here we have Q and P. Here we have A and B. Now I want to show you two things here. For a geometrical isomerism to be possible, for a geometrical isomerism is possible, Q must not be equal to what P, and A must not be equal to what B. Now this is when geometrical isomerism is possible. So geometrical isomerism is possible. Geometrical isomerism is what possible. Geometrical isomerism is what is possible. We are going to look at that. So when this is not equal to this and this is not equal to this, geometrical isomerism is what is possible. But if Q is equal to what P or A is equals to what B. Look at something here. If Q is equals to P or A is equals to what B, that is they are the same. Geometrical isomerism is not possible. Geometrical is not what possible. Do that. Geometrical isomerism is not what possible. See, so we are going to look at this in detail so you will get the concept, because in the exam, a group of arcings will be given to you and they will ask you which of these exhibits geometrical isomerism. Do you have? So these are what conditions here. When Q is not equal to P and A is not equal to B, geometrical isomerism is what is possible. But on the other hand, if Q is equal to P or A is equal to B, geometrical isomerism is not possible. Do you get? Now, geometrical isomerism is divided into two parts, cis and trans, and what E and Z. In this video here, I want to look at the cis and trans. But now let's look at what some of the arcane that undergo geometrical isomerism and some of the arcane that don't undergo geometrical isomerism. For example, here we have C. Okay, look at something here. When you have this structure here, now they will ask you, is geometrical isomerism possible, right? So therefore, you want to look at what these two carbon atoms here are here. So yeah, these two are the same. These two are not the same, and these two are not what the same. Look at something here. I think that for a geometrical isomerism is possible. For a geometrical isomerism to be possible, this must not be equal to this. That the two atoms attached to a single carbon atom must not be the same. The same thing with here. These two must not be what be the same. If you look at this two here, okay. Now here I think that geometrical isomerism is what is possible. Geometrical isomerism is what is possible. Why? Because this is not equal to this, and this is not equal to what this. Now, yeah, is geometrical isomerism possible? No, because these two are the same, attached to the same carbon. Although these two are not the same, because these two are the same, geometrical isomerism is not what possible. Do that. Geometrical isomerism is not possible here. Why? Because these two are the same. So when a structure is being given to you, you are being asked to identify if geometrical isomerism is possible or not. Therefore, you really want to draw this structure like this before you can actually what identify that structure. Do that. So let's see if we can take some example. So let's check if geometrical isomerism is possible here. You get so let's check if geometrical isomerism is possible here. If you share this structure here, 1, 2, 3, 4. So here we have 4 carbon atoms. 1, 2, 3, 4, right? Now there's a double bond between here, right? So here we have hydrogen, right? Because carbon must have a bond, 4 bonds. Here we have hydrogen. So remember, our focus is going to be these 2 points carry what the carbon atom, right? The double bond, right? So going to be hydrogen here, then this carbon, hydrogen here, CH2. So this is what the structure of 1, 2, 3, 4. Now this is structure for this one here. So remember, for geometrical isomerism to be possible, these two must not be the same, because here we have 2 hydrogen here. So geometrical isomerism is not possible. Geometrical isomerism not possible. So geometrical isomerism is not possible at this point. Why? Because here we have two the same atom attached to the carbon atom carrying a double bond. Do you get? So geometrical isomerism is not possible here. Let's check this other one here. So let's look at this one here. So here we have a cyclo compound, right? Cyclo compound directly what attached to this carbon, right? This carbon, these 2 carbon atoms are carrying what a double bond, right? Then this carbon atom here is carrying 1 carbon here, a carbon here. You get that? So If you look at this structure very well, yes, you're going to be CH3, you're going to be CH3, right? You're going to be what? Hydrogen. Is geometrical isomerism possible? If you check it very well, if you check this very well, these two carbon atom, hydro bond. Now, if you look at this one, this carbon atom is carrying is cyclic compound and what hydrogen, they are not the same, right? At this point, it's okay. But when you look at this carbon atom here we have a methyl and what an emethyl. This is that methyl and what an emethyl. Because these two are the same, geometrical isomerism is not possible. Geometrical isomerism not what possible, not what possible. So geometrical isomerism is not possible at this point. So let's look at the last one. So here we try some art. Look at this one here. Here we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, right? So I count back 2 and 3. There's a what? There's a double bond. So here we have hydrogen, hydrogen, what? Hydrogen, right? So we have hydrogen, 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 hydrogen. Just that. So you can also be written as CH3. Now it's bonded to what this carbon to carry what double. Here we have hydrogen, right? Double here. Here we have CH2, CH2. Here we have what? Hydrogen. Just that. Is geometrical isomerism possible? Yes. Yeah. Of course, geometrical isomerism is what is possible because these two are not the same and these two are not what the same. Therefore, geometrical isomerism is what possible. So if you try to ask, then this is what. So you can see how to identify alkenes that can exhibit what geometrical isomerism. So you have to draw the structure like this first to know if the carbon atoms kind of bond have the same compounds or atoms or different what atoms. The next one we want to look at what is what cis and trans isomerism. What is cis and trans isomers? So in the sense that for trans isomers to occur in what alkene, then the two carbon to carry double bond must have hydrogen. And then any other word group, do you get? So now these two groups can be on the same side or can be on the what opposite what side, or can be what on the opposite what side. So these two are not the same. So for a central isomers to occur, the two carbon atoms must have hydrogen. Do you get? There must be hydrogen on both carbon atoms. Do you get? That is only when central isomers what will occur. Do you get? So if for example now the two groups are on the same side, here we have the cis, right there, the cis isomers, the cis what isomer. So when the two groups are on the same side, here we have the cis. But when they are opposite side, here we have what the trans isomer, trans what isomers. So you really want to what pay close attention to this stuff here. So if for example here we have CH3. So they should ask now, what type of geometrical isomerism occur at this point here? Now, if you check very well, the two carbon atoms have hydrogen, right? So cis and trans isomers is possible. Now, when you look at these two groups here, they're on the same side. They can either be up or down down. So now, because they're on the same side, it's called what cis. It's called what cis. Now, the name of this compound is called what 2-butene. Do you get that? So now when the compound is being given to you like this, I say give the what structure. They want to give them as what cis 2 what butene. On the other hand, we have something like this. Now these two are what are in what opposite what position. So it's going to be what trans 2 what butene. Do you get that? So this is everything you need to understand about geometrical isomerism, and we are looking at what cis and trans isomers. In my other video here, I'm going to solve more problem. Then I'm going to look at what the E and Z isomerism. We are going to talk about the priority rules or the sequence rule. You really don't want to miss out that video because most of the stuff you're going to see in your exam, you're going to be what other what the priority rule and what E and Z what is made. I hope this video is helpful. Please, if you are not subscribed to the channel, please hit that subscribe button and turn on the notification bell because you don't want to miss out every single content we drop. You can share this video to your friends who are looking for this kind of what content. Thanks for watching. You can check out this next video.